nowadays people are looking more and more for these machines to function kind of like the consumer electronics they're used to, the Xboxes and things like that. They want to be able to press one button and have 5 functions happen.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, we ask that you follow us on Twitter. You can find us there at the NFPA. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is, in fact, one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on Apple Podcasts. We're on Spotify. We're on a lot of the other podcatching services. Wherever you find us, subscribe and then give us a quick rating. Those ratings really do help spread the word, help our friends in the industry learn about the show, and then join in on these important conversations. On today's show, our guest is Russ Farrell. Russ is the Applications Engineering Manager at HED Controls, a leading designer of electronic control systems for mobile equipment applications. And today we invited Russ into our forum to learn more about their solution for increasing fuel efficiency in hydraulic refuse vehicles. Russ, welcome to Fluid Power Forum.
Thank you, Eric. Glad to be here today.
We're glad to have you on the show. I always love talking about exciting applications of fluid power, and I think you've got a real interesting one for to talk about. But before we go there, tell us a little bit more about yourself. How did you find yourself working at HED?
So fresh out of college, I worked in the printing industry as a controls engineer for about 8.5 years, and just looking for a change. And there was an opportunity at HED in the application engineering group. It's kind of a mix of software controls engineering and sales support. It was a nice difference, so gave it a try. And 14 years later, I'm still here.
And have you done any fluid power work before coming to HED, or was it a new technology for you?
It was completely new for me. The hydraulics, I knew, right, at engineering school, you're going to get some general engineering classes, so right. I knew of it, but that was about it.
Were you a mechanical engineering student, or?
No, I was an electrical engineering student.
Electrical,
specifically focused on computer engineering.
Even further from fluid power, unfortunately. Although we need more and more electrical engineers every day, and I guess we'll get into a little bit of that as we get through the conversation here. So. I'm curious, what were your first impressions of fluid power when you started to actually work with it?
Well, it's kind of nice, right? We've got the gateway of the valve and the coil that, I could understand that. And, you're sending electricity and it moves it. And then, understanding the basics of hydraulics, I was able to get right into it.
That's great.
And really like the fact that HED, it's a different application almost every day that you're working with. So lots of variety.
Yeah, well, tell us a little bit more about HED as well. Then, what kind of company is it, and what do they do?
So we've been around for a little over 35 years, and we started off by making controllers for hydraulic systems. So the electric controller that would interface to the coil to then run logic to turn the hydraulics on and off, and then we expanded from that to adding displays to the system. And our latest endeavor has been telematics. So. Remote monitoring, collecting data, things of that from these machines. There's a lot going on and a lot of information there for the OEM and the customer to know to help keep things running smoothly.
What are there particular applications or particular machines that you work with at HED? What markets are you primarily in?
Pretty much any market that uses fluid power. We're in utilities, construction, refuse, that's the topic today, fire and rescue, defense, kind of all over the place. Pretty much anywhere there's hydraulics today, there's usually a controller attached to it.
Is it more mobile equipment of some kind, or are you in the industrial plants as well?
Mostly mobile, a few stationary things, but for the most part, it's mobile.
So any kind of vehicle that has hydraulics that need to be controlled, you guys we'll find HED products on those machines.
That is correct.
That's great. Well, I know, like you said, we wanted to talk about a unique application for a refuse truck as part of our discussion today. Was this the solution that you came up with? Was this an issue that a customer had brought to your attention that they needed a particular solution for? Or how did this come about?
So it's usually we'll either find or the OEM will find us, and they're today they're looking for smarter and smarter vehicles, right? Traditionally in the past, it was more just trying to get into electronic controls for the hydraulic systems. Just the general efficiency gains you get from that, the self-diagnostics that the machine can then do. And so it's just trying to find a way to help them differentiate their vehicles from their competitors, right? What's that extra feature we can help them provide, or just ease of use, right? The easier to use, the happier the operator is going to be.
Yeah. And so, I mean, from a colloquial sense, we're thinking garbage trucks here is what we're talking about, or is it a different kind of vehicle?
Well, today it's garbage trucks, but it can be, pretty much any of those. And my background, honestly, with HED has been a lot more with cranes, although I have done a few refuse truck projects.
Okay. And, so what are some of the issues that need to be solved? I would imagine efficiency is one of the issues that needs to be continually improved in those applications.
That's definitely one of them. And another one is just building the machine, right? Using the controls, you greatly reduce the wiring on the machine. So you have all of the direct control wiring where the module is, but from between modules, you're just running 4 wires. Whereas traditionally, where everything was point-to-point wiring, you've got these massive wiring harnesses of sometimes 100 wires in them, running the whole length of the vehicle. I mean, it's expensive, it's difficult to maintain, it's difficult to install. So by going to these control systems, you're reducing all of that. It makes it a lot easier to maintain, to install. And then, of course, now, instead of just a copper wire, you basically have all these computers all over the machine, so they can detect when wires break or things aren't moving correctly. So instead of the operator sitting there and just finding out that the machine's not doing what he wants, you could actually put on the display, hey, this wire at this fob in the truck is broke, or whatever the issue ends up being.
So we're still talking about the control of the hydraulic system, or we're talking about other systems on the truck as well?
Both, but definitely on the hydraulics.
And so, what kind of functions does the hydraulics typically do in these applications?
So for on a refuse truck, there's a couple of major functions, right? Either the forks in the front, if it's a front loader, or the arm on the side. All of them have a packer to crush the refuse that they're picking up so that it takes up less space. The cab functions that I alluded to with the display and lighting control, that's a side thing we tend to do with our control systems, is help give them control of all the different lights on the vehicle, right? The beacons on top, or work lights. So they could press a button on the display to turn them on, things like that.
Is there a connection between the fuel usage of those vehicles and the amount that the hydraulics is used? And I mean, is that part of what you're trying to solve here?
That's definitely something we can help monitor. Most of the engines that are interfaced with them, we can keep track of the fuel usage that the engine's reporting, the RPMs it's running at. Looking at the data, maybe that they're running it at a higher RPM than they need to for the job.
Right.
So, run it at a lower RPM, you're going to use less fuel.
So let's talk a little bit more then about what the unique solution is that HED is bringing to this environment. It sounds like I've been trying to kind of pinpoint it onto one piece of the vehicle, and it sounds like it's more expansive than that.
It is. We can interface, like I mentioned, right, with the engine, the chassis, and then the full system that they're controlling. So you could take it, basically take the machine. So now it's a full refuse truck by wire, right? They can just press a button and the arm would go out, grab the can, lift it, shake it. So you can get some, I wouldn't say automation, but automation-like functionality on it. Make things easier that way. And like I said, on the maintenance and reliability side, The ability of the machine to self-diagnose any issues that might be happening really reduces the downtime on the machine.
I would imagine so. So yeah, let's talk a little bit more about that automation aspect to it. That how much of that is being computer programmed, for lack of a better word.
It's to some extent up to the OEM and their customer base. That's a change I have seen in the markets we serve in my 14 years at HED. There was a lot of resistance to controls and new things early on. And nowadays, people are looking more and more for, these machines to function kind of like the consumer electronics they're used to, the Xboxes and things like that. They
Right.
want to be able to press one button and have 5 functions happen and things like that.
That's got to be an interest. I mean, we've heard that theme on the show from several guests, in terms of it's not as simple as it may sound to have a machine, automatically perform a hydraulically driven function. So how much feedback does the system need to have in order to know where things are and to do those things automatically?
It comes down to how much you're moving out in space. Obviously, the more likelihood of you to encounter a collision or somebody walking by or something like that, more and more feedback that you're going to need, or at least the ability for operator interaction. The more enclosed it is, the less you would need, but it's definitely, you need the sensors there to know where, whatever you're moving by hydraulics, where it is, what it's going, what the pressure is. I mean, that's why everybody uses fluid power, right? It is such a powerful tool for getting things done in these industries that you do have to be careful with it and make sure that you have the proper safety in place.
Yeah, I mean, like you said, it's there certainly is a trend to away from human operation on a lot of these tasks, even though the machine itself is still using the hydraulic technology to accomplish it. It's probably because there are fewer and fewer trained operators on a lot of these vehicles.
That would be part of it, yeah. Repeatability would be another one, right? It's always going to be done the same way.
Right. And that gets back to the efficiency part of it as well, right? So,
right.
All right. Well, we're going to take a quick break in our show right now and provide an update to our listeners on some other fluid power industry opportunities. But we'll be back in just a couple of minutes with more of our discussion with Russ Farrell of HED Controls. Okay, we're back from the break. And again, I'm talking with Russ Farrell of HED Controls. And we're talking about electronic control of hydraulic systems on refuse trucks and some of the innovations that he and his company are helping to bring to those customers in the hydraulic space. And Russ, I'm wondering if you can help us, if you were to highlight some of the most recent projects that you've done, what were some of the objectives that you're trying to accomplish on these vehicles?
So some of the more recent ones was a commonizing of the platform that we provide, reducing the number of types of modules, and also a lot of work around the display in cab for the operator feedback, right? The more information you can give the operator so he knows what's going on to better do his job.
What kind of information are we talking about is it like a dashboard of some kind that they're looking at?
Yeah, a dashboard specifically for the body, in this case, the refuse vehicle, right? You could tell it, how many times they've lifted things up. You can alert any issues you're detecting from the hydraulic system, right? If you see an over and under pressure somewhere, or if you're, let's say commanding the arm up to lift the garbage can, if it's not moving, you can provide that feedback to the operator. Obviously, like I said, the number of garbage cans he's lifted, right? It gives him a rough idea of how much he's carrying before he has to go back to empty it, unless you're going to use some type of a loading or volume-based sensor to detect that directly.
Mm-hmm.
And engine performance, as we mentioned before, with the fuel usage, loading on the engine, things of that nature.
How much, do you have any sense of or data on like what the fuel savings could be because of the implementation of these new systems?
I'd have to go look that one up. I don't know that off the top of my head.
But conceivably it would be significant of some kind.
But I know in other industries and other applications, they've seen pretty significant ones. like the craning industry, right? If it's on site, or most construction, right? If it's on site, it's usually running. And typically you want it to run at a higher RPM for better flow for your hydraulic system. But if they're not actively functioning the machine, you want it at a lower RPM for the fuel savings.
Okay.
So you can get it where it automatically detects that. You
mentioned earlier preventative maintenance as another capability that these systems provide. Can you talk a little bit more about that? What do you mean by preventative maintenance?
So there's a wide variety of things you can do, right? I mean, it's a hydraulic system, so you have your hydraulic filters to keep it clean, right? And those are usually time-based maintenance, so we can keep track of that and alert the operator that it's getting close. Other ways you can check it is also through cycles, right? How many times have you run the packer? How many times have you lifted the arm? Things like that. And there's typically a maintenance schedule around those for the different grease points and things of that nature. So you can keep track of all of that and just notify the operator through a display or other system to let them know that they're approaching those, so that when they bring it back, it can have the maintenance it needs at the scheduled downtime for the vehicle, instead of having an issue while it's out running the route.
Yeah, that's one of the most important pieces of all these different puzzles, is that you don't want unplanned downtime for any machine that has to do work in the field, because it's not earning any money, basically, if it's not working when you need it to be working. So
yes.
What other kinds of data are you collecting, either from the hydraulic system or from the machine itself?
So for the telematics enabled ones, you can get almost anything that's a sensor or what's going on or any function, right? So you can keep track of all of it. You can get a better understanding, or the OEM can get a better understanding of how the vehicle's actually being used. We mentioned some of the automated tasks. You can actually see, are they using the automation, or are they still doing it manual through the joystick, things like that.
Mm-hmm.
Then of course there's the whole analytics side, where you take all the big data, right, and you data mine it, and you try to find other things that, if these 10 things happen, that means this is going to happen in the future. For, again, preventative, right? Try and find issues before they become issues.
I would imagine that some people are keeping track of that at the vehicle level and others at the fleet level, if the whole fleet is equipped with this kind of technology.
Yes, it would be both down to the vehicle and the fleet.
Yeah.
The service manager for the fleet, again, just for all the standard scheduled maintenance, keeping track of what's coming up.
Now, these control systems that you're talking about, are they, do they only come on the new vehicle, or can they be retrofitted on existing vehicles?
Typically they're on the newer vehicle, but some of them can be retrofitted. The data collection, the fleet management, those can usually be retrofitted. And to the other side, it depends on what was existing, right? If it's completely point-to-point wired machine, it's a little more difficult to rip all of that out. But if it had maybe an earlier generation of a control system, you can maybe add on a new one or modify the existing one.
Have you had any particularly interesting or challenging retrofit projects where you needed to install something?
We do occasionally get, just because, that is one of the big things with electronic controls, right? The electronics industry moves so fast, things become outdated, right? It gets updated. Think of how quickly your cell phone is considered updated, and they're outdated, and they're trying to get you to get a new one, right?
My cell phone itself asks to be updated almost weekly, it seems. So,
So along those lines, you do have occasionally where things will go obsolete, right? So you'll have a system in the field and you can't get the parts for that module. So you have to find a way to take a newer module and make it at least act in the system like the old one. We've done some of those. Sometimes you can have new features added, right? Where you'll just bolt on another controller or two. Maybe they want slightly finer control on the arm. It's lifting the garbage can or something like that. And so you'll bolt on another module that's basically, it's a system all to itself that gives something in the field newer features that it didn't have before.
Yeah, I mean, one of the things that I always find so interesting about these discussions, Russ, is that the muscle of the motion is still kind of the old-fashioned dyed-in-the-wool hydraulic type stuff. We're talking about pumps and hoses and cylinders and doing it that way. But increasingly, there's this ability and need to connect that muscle to a smarter and smarter control algorithm or control brain, if I can use that analogy. And that's really what it sounds to me like what you're talking about, that it's this weird connection between a mechanical system and an electronic control system that allows greater efficiency and greater usage of the technology. So it must be exciting to be on the cutting edge of that kind of innovation.
It really is. It's been a joy to be working on that. We've got systems that will do a system for somebody, and then every 6 months they're coming back with new ideas. So it's not new hardware; it's just new software to use what's there differently, to add new features, to add better control. Maybe add a dampening feature to the joystick to the arm control, right? So it's a little bit of a smoother reaction of the arm as they're lifting the garbage can or things like that, to just make life easier for the operator, right? The easier it is, the quicker you can do it, and the better his job goes.
It's almost like it's keeping the hydraulics as part of the future of the technology, because the electronics is allowing for those better and finer controls.
Exactly. I mean, I don't foresee hydraulics going anywhere anytime soon. Just the power of hydraulics, your weight and cost ratios for what you're getting out of it. I mean, that's why it's everywhere, right?
Right. The sleeping giant, as we sometimes call it, right? So what do you think is next? Can I ask you to look into your crystal ball? Like, what do you think the next innovation in this space is? Is there something you guys are working on in the skunk works right now, or what's next on the horizon?
So the two big things we see coming are electrification and autonomy, right?
Right.
And I don't think the electrification is going to replace the hydraulics. I think that's just going to be that the powertrain of the vehicle now is going to be electrified instead of it being diesel.
Right.
Just because, again, the power, the standard Packer cylinder is running at 2,000 psi on a garbage truck, right? I mean, that's not going to be replaced by an electric motor anytime soon.
Mm-hmm.
So it'll be interfacing the hydraulics to the electrical ground drive, and then just autonomy, right? Everything from starting small with one small feature, you make it where it becomes a push button instead of a joystick operation, to, eventually I think most of the refuse trucks will be driving themselves and running the routes.
Yeah, that's an interesting vision for the future. I mean, we're seeing, like in agriculture, I know a lot of those vehicles are fully autonomous at this point. They're not only driving themselves, but performing their functions. That's a much more controlled environment, I would guess, than driving around city streets where cats and dogs and children sometimes are running. So.
Exactly. I mean, that is one of the big differences, right? Agriculture is on the leading edge on a lot of it, but they do have that advantage that it's a more confined, controlled environment that you're in.
Right. You think that's really one of the barriers here? I mean, how would we solve that?
It's a good question. Obviously you're seeing a lot of it from the car industry where they're trying to do it. And I think we'll just start leveraging some of that technology and go from there. It won't be tomorrow. It'll be a little farther out than that, but I think that's the direction it's headed.
That's interesting. Yeah. Well, that's exciting. Maybe we'll have you back on the show in a couple of years when you figured out how to do a fully autonomous refuse truck then.
Sounds great.
All right. Well, great. Well, that's going to wrap things up for this episode of Fluid Power Forum. My thanks to Russ Farrell of HED, who has been my guest on the show. If you'd like to connect with him, learn more about what he does, and learn about his company, you can do that via his email. And we're going to put a link to that address in the show notes for this episode. Remember, if you like our podcast, please follow us on Twitter. You can find us there at the NFPA. And make sure to keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We do want to hear from you about the kind of topics we should be addressing on our show. Also, to see the latest fluid power technology and learn from industry experts, make your plans now to attend IFPE, the International Fluid Power Exposition. Our next show will be March of 2023 in Las Vegas, Nevada. For more information, visit ifpe.com. Fluid Power Forum is a podcast of the National Fluid Power Association. We are ably produced by Maddie Parise, NFPA's Communications Manager, and I'm your host, Eric Lanke, reminding you to join us next time in the forum.